Hi all, I'm K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see a topic known as Hall effect transducer based on the design thinking approach. So design thinking is nothing but a human-centric approach. Uh, where it has five stages: empathy, define, ideate, prototype, and test. So before going into the understanding the Hall effect transducer, let us first think about real world problem. So in industries and automation systems, there is often a need to measure position, speed, or current without physical contact because contact based sensors experience wear and tear and require maintenance, and also it have short lifespan. So therefore, engineers need a sensing device that is reliable, accurate, and capable of non-contact measurement. So this user need represents the empathize stage of design thinking. So now let us define the problem clearly. So the challenge is to develop a sensor that can accurately detect the magnetic fields and measure physical quantities such as position, speed, and current without direct contact. The sensor should be durable, fast, and reliable. So this is the defined stage of design thinking, and the solution to this problem is the Hall effect transducer. So the Hall effect is a phenomenon in which a voltage difference known as the Hall voltage is generated across a conductor or semiconductor when an electric current flow through it and a magnetic field is applied perpendicular to the direction of current flow. This effect was discovered by Edwin Hall in 1879 and forms the basic operating principle of Hall effect sensors and transducers. The generated Hall voltage can be measured and used to determine the strength of the magnetic field. So to understand the working principle, you consider a semiconductor carrying current. So when a magnetic field is applied perpendicular to the current direction, the moving charge carriers experience a force that pushes them towards one side of the material. So as a result, charges accumulate on one side, creating a potential difference across the conductor. This voltage is called the Hall voltage. The magnitude of the Hall voltage depends on the magnetic field strength and the current flowing through the conductor. The force acting on the charge carriers is known as the Lorentz force and is given by the equation F is equal to Q into V into B, where F represents the force acting on the charge carrier, Q is the charge of the carrier, and V is the drift velocity, and B is the magnetic field strength. So this Lorentz force is responsible for the separation of charges and the generation of Hall voltage. So moving to the ideate stage of design thinking, engineers brainstorm various ways to use Hall effect technology. Some possible application include current sensing, speed measurement, proximity detection, position sensing, motor control, and magnetic field measurement. Among these solutions, all effect sensors are preferred because they provide accurate measurements without physical contact and offer high reliability. So Hall effect sensors are mainly classified into three types. The first type is the analog Hall effect sensor, which provides a continuous output voltage proportional to the magnetic field strength. These sensors are commonly used for magnetic field and current measurements. The second type is the digital Hall effect sensor, which provides a binary output either on or off when the magnetic field exceeds a predefined threshold value. These sensors are widely used in limit switches and object detection systems. The third type is the latching Hall effect sensor, which maintains its output state even after the magnetic field is removed and changes its state only when an opposite magnetic polarity is applied. So these sensors are commonly used in motor control and security applications. The Hall effect transducer consists of a semiconductor sensing element, constant current source, and a signal conditioning circuit. During operation, current flows through the semiconductor material, and when a magnetic field is applied, Hall voltage is generated across it. This voltage is then amplified and processed to obtain the desired output signal. Since there is no physical contact between the moving parts, Hall effect transducers provide long operational life and excellent reliability. So the major advantage of qualified transducers include non-contact sensing, high reliability, fast response, compact size, low maintenance requirements, and suitability for harsh industrial environments. So these advantages make them highly popular in modern measurement and control systems. Some limitations are mechanical stress, nonlinearity, offset voltage, and temperature sensitivity. So Holified transducers have a wide range of applications in the automotive industry. So they are used for wheel speed sensing, crankshaft position sensing, and anti-lock braking systems in industrial automation. They are used for proximity sensing and motor control. And in power electronics, they are used for current measurement. In consumer electronics, such as smartphones and laptops, Hall sensors are used for magnetic switch detection, and they are also widely used in robotics for position and motion feedback. So, in the prototype stage of design thinking, engineers can develop a prototype using a Hall sensor, a magnet, and a microcontroller. So, the sensor detects changes in the magnetic field strength and converts them into electrical signals. So, this prototype can be used for speed sensing, position detection, or current measurement applications. Finally, in the test stage, the developed prototype is evaluated for accuracy, sensitivity, response time, and reliability under different operating conditions. Based on the test results, necessary improvements can be made to optimize the performance of the sensor system. So to summarize, the Hall effect is the generation of a voltage across a conductor due to the presence of magnetic field. So it operates based on the Lorentz force principle and forms the foundation of the Hall effect transducers. These transducers are available in analog, digital, and latching forms and are widely used in industrial, automotive, power electronic, and consumer applications. By following the design thinking process of empathize, define, ideate, prototype, and test, engineers can effectively develop practical Hall effect based sensing solutions for real world problems. Thank you for watching this video.